Welcome back everyone. In this tutorial we're gonna take a look at a free damped vibration with an initial velocity and an initial displacement. We also have the damping ratio given, and out of these, let's see, maybe we'll calculate it for the 100% one. Alright, let's get started. First up, go to model and set up our nodes. First point, first node at 0 0, second one at 1 0. Okay, cancel that out, press Ctrl Q and visualize the nodes. Done, there you go. Now we can see our two nodes. Then let's go to model and set up our property. I'm gonna call it my spring. At the element property type, make sure you pick spring damper. Okay, here we're gonna make sure that the C bush is selected, stiffness is gonna be 100, and the damping, well, let's see, the damping was given as 100%. So for that we're gonna go ahead and calculate it. Right here we have M, K, and damping ratio given. We're gonna use these two formulas. The critical damping constant we can calculate for mk under the square root. 100% is 1, therefore plug in, and here you go. C equals 10. C is the damping constant that we need to plug into Femap right here. That is 10. Alright, click OK. Cancel. Now let's set up our element. Select my spring between node 1 and 2 right here. Click OK, and there you go. We have our spring damper setup. Now we're gonna go to model and set up our point mass. So just put mass, element property type. We're gonna go all the way down here to mass. Click OK. We're gonna enter 1 kilogram for our mass. Okay, cancel it out. Now let's make an element which will relate the point mass to node number 2. Here, mass, and at node number 2 right here. Okay, cancel. There you have it. Now we can set up our boundary conditions. Constraint nodal, put BC. On node 1 we're gonna do call it left, we're gonna do pinned. Okay, on node number 2, okay, we're gonna do right, we're gonna allow translation in X, but we're gonna zero out Z and Y. Click OK, cancel. Okay, very good. Now we can go ahead and set up our initial conditions. So we need initial velocity and initial displacement. We don't have an option straight up here that tells us that, so we need to remember that we need to go under load. So load nodal, this is gonna be IC for initial conditions. Okay, and we're gonna apply it at node 2. Click OK, and this is where we're gonna have the option to pick. First I'm gonna enter initial velocity, so let me call it init velocity. That's gonna be in the X direction a value of 0.1. Okay, cancel it out. Oh, we need to add model, go back, load nodal, again at node number 2. Okay, and we also need to apply an initial displacement, which is also here a little bit further up at displacement, also in the X direction, so we're gonna put 0.005. Click OK and cancel, and if we zoom in, there you go. We have the symbol for initial velocity, symbol for initial displacement. Great. We are ready to perform our analysis. So let's go analysis, new, one. Make sure over here you pick not static, number 3, transient dynamic. Okay. Then we will go to options, go to dynamics, the not defined, open it up. Here we're gonna define our time steps. Let's say I want 500 time per step. This I'm gonna put 0.01. This is when you do hand calculations, this would be your delta t, and I'm gonna put 1 here for how many outputs do I want. Do I want it to print the result every single calculation that it does, or if you're doing a bigger calculation and you want to save computational time, you can set this to maybe I want to print only every 10th calculation. But since we want to do a smooth chart, we're gonna put 1 to make sure it's not gonna be choppy. Okay, go to masters, boundary conditions, open these up, make sure these are set correctly, because if not, it's absolutely garbage what we're gonna get. Constraints BC on your model tree, you can verify, right? Our constraints, we named them BC. Make sure that's what's selected. Loads, this is incorrect. We do not have any loads. This is free vibration. Make sure none is selected. Now for initial conditions, we here need to make sure we select IC. That's what we set up here for our initial conditions, right? We have initial velocity, initial displacement. Okay, and that's it. We can, if you want, you can go to preview input. These are the Nastran cards. We're gonna have some videos on Nastran cards, so make sure you check them out if you want to understand more of what's happening here. But just a quick check, see these two? This line is the initial conditions. This one is our initial velocity. This one is our initial displacement. Okay, you don't need to click on this one if you don't want. You can just go straight to analyze. Let the solver do its thing. Complete, no errors, very good. That's what we wanted. Now we can go ahead and close that. We can go ahead and chart our result. Go up here, new data series. I'm gonna call it displacement versus time, vector versus set, output set value. Down here we had a translation in the x direction, t1 translation, that's translation in x, and at location number 2, that's where our action was happening, right? And click OK. Bam, there you go. We have our result visualized on a nice chart with 100 damping ratio. Wow, that damped it down real fast, huh? And if you zoom in, you can see when we started the simulation, we set up 2 initial conditions. Initial displacement was not 0, was 0.05. So see, at 0 times 0, displacement 0.05. And the slope of this curve right here at the initial condition was 0.1. So if you would calculate the slope here, that's what it should be. There you go. Well, this concludes our simulation. Thank you guys for watching. Make sure you like and subscribe and tune in for the next one. Have a good one.